Yeah, to welcome today's speaker, I'm replacing Niels, who cannot be here in person, unfortunately. But then it's my pleasure to welcome you today to the seminar and also introduce you to our audience. Nick Diakopoulos is an associate professor at the Northwestern University in communication studies and computer science. And he also has a second associate professor position at the University of Bergen in media studies and information science. Nick's fascinating research revolves around computational journalism with a focus on how AI and automation are impacting the news production and news distribution. And if you're interested in this topic, I can really recommend you the book written by him, Automating the News, How Algorithms Are Rewriting the Media, published by the Harvard University Press. So Nick is currently at a sabbatical at the University of Amsterdam, where he also met Niels, and where Niels, for the great pleasure for us, took the chance to invite him to our seminar. And with that, I will leave the stage to you just up front. Usually we have a very open, like, how would you handle questions? Would you rather have it like in an open fashion that we can ask you in between, or rather at the end? What's your personal preference?
Yeah, I'm open to taking questions, fielding questions as we go. That's fine.
Okay,
yeah.
Fantastic. Okay, I keep an eye on the online audience and then
Sure.
let you know if there are any questions coming up. Fantastic, then.
Perfect. Well, thanks so much for the invitation to join today and for the introduction, Clara. You know, so I've been spending the year at the University of Amsterdam, actually in the law school of all places, which is a little bit of fish out of water for someone like me who has a PhD in computer science and human-computer interaction, but is now appointed in a communication studies department and now visiting a law school. And so I'm trying to combine different facets of my work life here and try to connect some ideas I've been thinking about related to algorithmic accountability, algorithmic transparency, and now where things are going in terms of AI governance in the EU AI Act. So I'm gonna try and connect these threads and just to share a little bit about what I'm thinking in this direction. It's certainly open to feedback, open to questions, and having this, you know, be seminar style, have a little bit of a learning experience for me as well. So I'm going to start with this. So, you know, there was this recent debate between Yuval Noah Harari and Yann LeCun, where they discussed a wide range of issues around AI and society, talking about the definition of intelligence, labor impacts. Of course, everyone likes to talk about those, other kinds of safety concerns, you know, how generative AI is going to hack democracy, you know, minor stuff like that. And what was interesting to me about this and sort of reading this debate was how these two guys had very different ideas of how they thought the future of AI was going to impact society. There were certainly some similarities if you kind of read the responses to the questions they were talking about, and some similarities in terms of the trends that they were identifying and where they were going, but they were sort of interpreting things differently. And the reason I kind of wanted to start here is I think there's a pretty big focus right now in terms and an interest in trying to anticipate what is going to happen with AI, and particularly the latest kind of hyped wave of generative AI, and how that's going to evolve in society and impact not only the near term, but also the medium and the long term. There's a lot of uncertainty there, right? There's disagreements by individuals, and those individuals see the world in different ways, but they're kind of making a best effort to develop foresight into how they think society may shift in response to this technology. So I think what these guys are debating is an illustration of this idea of perspective cognition. This probably isn't a surprise to anyone sitting in this room. People routinely and frequently think about the future. Think about, you know, the last time you daydreamed, or the last time you made lunch plans with someone else who's really busy. you know, there's a lot of planning and prospection that we do on a daily basis just to get through the day. And this is a really fundamental aspect of our existence and our cognition, to think about the future. We engage in future-oriented cognition about our lives. We set goals, we make plans, how to reach those goals. We predict, we mentally simulate how we're going to feel when we get there. And we imagine, you know, different possible futures. And different kind of intuitive understandings of social situations that could arise. And these imaginations then motivate us to shape our behavior now, so that we can either avoid the thing that's making us feel negative about the future, or try to bring about a version of the future that makes us feel positive. So in his book, Your Brain is a Time Machine, neuroscientist Dean Buonamano says, the brain is at its core a prediction or anticipation machine. So we're all engaging in this anticipation constantly. It's really core to human experience and how we go about planning and goal setting and so on. So how do we take this idea of prospective cognition and apply it to something like technology governance? Well, there's an idea that's been percolating for the last decade plus in the philosophy of technology community, and this is the idea of anticipatory governance. Anticipatory governance calls for the examination of the social impacts of emerging technologies while they're still in the early stages of development, and when that examination can influence future development. So in the domain of AI, I would argue that the anticipation of impacts of AI technologies is kind of a crucial element to understand in advance if we're going to be able to successfully govern it. Much as how, you know, prospective cognition shapes our behavior today so that we can realize the future that we want, anticipatory governance is sort of a collective version of that prospective cognition, where we're helping to shape the socio-material reality today in order to steer society where we want it to go, or towards appropriate goals. And as we can see reflected in forthcoming regulation like the EU AI Act, which the latest version just came out a couple weeks ago from the European Parliament, they actually call for a risk management system for high-risk applications of AI that includes identifying reasonably foreseeable risks. That's the phrase that pops up. And actually, this word foreseeable is mentioned 20 times in the latest draft. So it's not just like it appeared once there, but there's really an emphasis on foreseeability of risks. And here you can see in the verbiage here, I grabbed a snippet of the bill. There's verbiage as it applies to developing risk management systems for high-risk systems. This idea of reasonably foreseeable risks and misuse also applies to technical documentation requirements, transparency provisions, including those that will apply or may apply if the bill passes in its current form to the registration of foundation models on the market. Okay, so there's a regulatory need, a policy need to develop foresight, foreseeability, and anticipate impacts of AI in society. So how are we going to do this? We kind of need to think about an approach, not only conceptually, but also methodologically, for how to do develop this kind of foresight. Now, anticipating impact of new technology like AI is hard for a variety of reasons. The technology is going to evolve, it's going to intersect with human intentions, human agency, social dynamics, etc. And you're always going to have uncertainties related to technological development, policy development, social development, how societies respond to these things. And all these uncertainties, of course, have capability to shape which way the socio-technical environment is evolving over time, and kind of modulate the environment. So one way to, I think, conceptualize the challenge of foresight here is to cast it as one where we need to address the uncertainty and to try to reduce uncertainty about the future. So let's think about how we might be able to do that. So in thinking about this challenge of uncertainty in developing foresight and anticipation for governance purposes. We actually wrote a workshop paper a few years ago now at NeurIPS, kind of pulling in a framework for understanding 3 different types of uncertainty that are typically talked about in statistics literature. So we can talk about aleatory uncertainty. This is basically the fundamental indeterminacy of the world, right? There's randomness in the world. And I think you could probably put indeterminacy of individual agency and behavior in that bucket as well, things like intention, agency, and so on. And I think aleatory uncertainty is definitely the category that we're least likely to be able to mitigate. I think it's going to be really hard to try to reduce the aleatory uncertainty as we're thinking about the future. These are complex systems. Things are going to happen that we can't predict because of the randomness in the world. But there are a couple other types and forms of uncertainty that I think we can address. So epistemic uncertainty is basically about missing information or missing expertise. So this is a form of uncertainty that we can think about reducing as we think about foresight by, for instance, accessing specific forms of technological, policy, and societal expertise. So, for instance, broad societal expertise might be accessed by basically talking to a diverse array of individuals who have different perspectives on the social world. You know, if we're talking about epistemic uncertainty, we can kind of modulate by thinking about who is doing the anticipation. Who is doing the anticipation? But epistemic uncertainty can also be modulated by changing when you anticipate. So anticipating later in the development of a technology is already going to reduce knowledge gaps in terms of what the technical capabilities are. So by introducing anticipation later into technology, you already kind of have more information about where the technology is going. And then ontological uncertainty describes uncertainty about essentially the entire modeling process. So, you know, we build models as reflections or representations of reality, but of course, no model fully reflects the full richness of reality. And really, this gets at whether your model of the future adequately models the world. And here the question is, again, who is participating? Since I think more diverse people would be expected to be able to access a broader array of large world models and access a larger kind of coverage of the ontology of the model of the world that you need to consider in order to anticipate effectively. And so for the rest of the talk, I'm actually going to talk about some of our work in applying different methods to look at different stages when you're applying anticipation and by different people who is participating in anticipation, and offer some empirical results that we've developed. So I'm going to start talking about broader impact statements in AI research. And this line of work got kicked off in, I guess, late 2019. Although actually it goes back even into 2018 when a colleague at the time of mine, Brent Hecht, who's now at Microsoft Research, he and a number of other computer scientists actually wrote an essay calling for the CS community to take seriously an obligation to consider the negative consequences of their computing research. Now, it took a couple of years, but by 2020, NeurIPS, the premier kind of technical AI conference, they decided to run an experiment where they actually required authors to include a statement of the potential broader impact of their work, including its ethical aspects and future societal consequences. So in terms of the framework I set up before, this is kind of looking at anticipation relatively early in the development process at the research stage, and also specifically leveraging the expertise of the technical researchers who were doing who are developing AI technologies. So given this experiment going on, we kind of got curious about these statements, and we wanted to know what the researchers were actually writing about in their broader impact statements. This is the first time a major conference had this kind of requirement. So we kind of took an exploratory approach here and we scraped the almost 1,900 papers from the pre-proceedings, parsed out the broader impact section using regular expressions, and then we applied sort of standard qualitative coding, thematic analysis, memoing, analyst triangulation, that kind of stuff. Ended up looking at about 300 documents. The themes had saturated that at that point, so we felt like pretty confident that we didn't need to continue looking at more and more statements. After we identified themes in this collection, we actually went back and counted the prevalence of those themes as well. Now, so I'll share some of the findings here. Basically, there were a couple of high-level themes that I want to pull out and talk about. So one was how impacts were expressed and talked about by researchers in these broader impact statements. So people talked about different valences, positive, negative. They talked about different orientations of impacts. What I mean by that is some people focused on technical impacts. So how this new research was going to have some kind of technical implication. But they also sometimes talked about societal impacts. So that kind of that orientation between technical versus societal. There was a specificity dimension where people, maybe talked more about specific contexts of use versus more broad impact areas. And then there was certainly uncertainty that was discussed in the expression of these impact statements. Things like modeling assumptions, lack of guarantees provided by an algorithm, the idea that real world behavior of a system is uncertain, or that there's uncertainty around potential user errors or user input. Now, in terms of impact areas or impact types that we identified, there were, again, as I mentioned, societal impact areas. People talked about privacy, labor, environment, media, democratization, bias, and so on. So nothing terribly surprising there. You can see a little bit of the prevalence information. They also talked about technical impacts, things like efficiency, generalizability, robustness, accuracy, interpretability. And I think the thing I want to point out here is that you can kind of see from the prevalence data, these are non-mutually exclusive codes, but you can kind of get a sense from the prevalence data that the technical impact types are tend to be a little bit more prevalent, things like efficiency and generalizability and so on. Whereas things like labor, media, and democratization, those were a little bit less prevalent. Now, in some cases, authors did also make recommendations for how to mitigate impacts. So they not only talked about potential impacts of their research, but also what could you do to address those impacts. And we found that about 24% of the statements mentioned who might be responsible for addressing impacts, and another 7% made recommendations, but didn't assign a specific responsibility for doing something about the impacts. And so you can see some of the recommendations that were made, you can see they're responsive to some of the impact types in terms of fair outcomes, protecting privacy, reducing environmental harm, and that kind of thing. Yes, responsibility assignment was often to various stakeholders, sometimes closer to the deployment of the technology, but also sometimes to the researchers themselves or to the broader research community. Now, in 2021, the assignment changed a little bit. So the conference learned from feedback. It decided actually to make the statements optional in 2021. And it also changed the assignment to have authors focus on negative impacts. So not to talk about like the positive things that could come out of the research, but really to get people to focus on those negative things. So what we did in 2021, similarly, kind of scraped the papers. Because it was an optional exercise in 2021, there were only 768, which is about a third, that had impact statements. And again, we did qualitative coding. We took a random sample of 30% and we read them and looked at themes and developed clusters of themes. Just as a footnote, if you check out the paper here, there was a whole second part of this paper where we actually looked at the ethics review process in NeurIPS 2021. Well, because that was out in the open review, we were able to gather reviews that were part of the ethics review process for the conference. I'm not going to talk about those findings today, but they're in the paper if you want to check them out. So here are some findings from this 2021 analysis. And I think maybe particularly in light of the focus in 2021 on negative consequences, I think it's interesting to see particular themes around agency and responsibility pop up here. So agency refers to whether authors seem to believe that they had control over the identification and mitigation of negative societal consequences. Authors talked about how intentional bad actors or unintentional use of the system could lead to negative consequences. And they seem to place the threat of a negative impact outside of their research, outside of their paper, and rather more in terms of improper use, which to us seemed to suggest a lack of researcher agency for mitigating, or researcher feeling like they had agency for mitigating negative consequences. Responsibility here refers to, oh, and I have some quotes here. So in terms of the first theme of agency, you can see people talking about, well, this could be exploited by an adversary. This can be utilized for a variety of purposes beyond our control. So again, kind of, it's not our fault if it gets misused. It's someone else who has control over that. Now, responsibility, kind of the second two themes there, refers to authors appearing to take ownership over identifying impacts and detailing mitigation strategies. So sometimes authors actually fully denied responsibility, kind of minimizing negative impact, but also sometimes talking about mitigations. So for instance, one comment we had here was actually an example where the authors did, in fact, make an attempt to update their research to develop a new algorithm in order to address an environmental impact that they had identified. And then oftentimes you see researchers shift responsibility to practitioners and users or to the broader field. So in terms of assigning responsibility, for instance, they would talk about practitioners and the need for those practitioners to pay attention and apply in trying to apply the proposed method to real world situations. And then we also see an instance here of kind of diverting responsibility to the field. So people would kind of say, well, we didn't do anything new in this research, anything fundamentally new in this research that the rest of the AI community isn't already doing. So we kind of already know what the negative potential of this kind of research is. So it's kind of trying to push the responsibility onto the broader community and what's going on in that community. Okay, so just to summarize briefly, I think we saw that researchers are indeed able to identify impacts. They tend to be more technical than societal in terms of prevalence. Conceptually, I think there's some nice ideas here in terms of shaping the exercise. If more communities are moving towards requiring broader impact statements, we might want to think specifically about the instructions that we give researchers, indicating the specificity of the impacts, the orientation of the impacts towards technology or society, and also the valence, whether or not we really truly want them to focus on negative impacts. And ultimately, I think in terms of the responsibility assignment that's going on in those kinds of statements, it doesn't seem clear to me that researchers are necessarily the best people to be thinking about who should be responsible for addressing impacts. It's not necessarily bad for researchers to reflect on who might be responsible for mitigating impacts, but I think we probably need larger consensus building, norm building, and broader kinds of forums where researchers and other stakeholders can also talk about who is really responsible for addressing different kinds of impacts. Okay, so I want to also talk about some of our recent work thinking about participatory foresight. So I think one of the ideas that comes out of the studies of broader impact statements is we need to really think about this question of who is doing the anticipation. Who are we tasking with this idea of foresight for anticipatory governance? So experts may not be the only ones or even the best ones to generate foresight, since like any human being, they have a partial view of the kind of the social system that they're trying to anticipate. And again, I think they do have a certain form of technical expertise that I think is important in order to mitigate epistemic uncertainty in developing that foresight. But the idea is, I think, that many perspectives from many cognitively diverse individuals with different backgrounds, experiences, expertise, perspectives on the social world, that's ultimately going to paint a more nuanced, faithful picture of the future of AI impact and safety issues. So the idea of participatory foresight is really that we should involve many more stakeholders in the anticipation process. And of course, there's many different methods we can use to do that. There's envisioning workshops, there's large public forums with diverse individuals who can contribute ideas about the future. But in this work, I'm going to present actually an exploration of a survey method that we developed to try to approach this idea of participatory foresight. So this actually built on some data that we had captured in another system that we had built. So this is the algorithm tip system described in this paper from CACW from a couple of years ago. The system is built for journalists to basically enable algorithmic accountability reporting. And what it is it's a large database of instances of government use of algorithmic decision making. So we go track, we find documents from local, state, and national governments. We annotate them, we summarize them, we put them in this database, and then journalists can sign up for alerts for algorithms that might be interesting for them to investigate. Kind of give them that first inkling that there might be a story that they want to dig into. Now, down below in this interface, you can kind of see this section at the bottom called crowd ratings. One of the goals of algorithm tips was to see how we could support newsworthiness decisions for journalists, to inform them about what might be interesting for them to pursue. And so we actually took the summary of each algorithmic decision-making system and posted it to Mechanical Turk and asked for numeric ratings as well as explanations of those ratings. So down here, for instance, for negative societal impact, we would ask the crowd to give a numeric rating and then explain what the potential negative societal impact would be of this ADM. So we've been running this for a couple of years. So I was kind of looking at the data and thinking, maybe we could actually repurpose this data to look at this question of participatory foresight. So that's what we did. So we had data for about 2.5 years. We had collected about 765 ADM systems in government. That was about 3,800 ratings for negative societal impact. But we had to filter some of those ratings. Anyone who's used Mechanical Turk knows that there's quality issues. We did the best we could in trying to maintain the information quality there. But we ended up having to filter that down to about 2,500 ratings. And then we did topic modeling. So just kind of standard LDA topic modeling here. We did a little bit of manual refinement of the topics, and we ended up with 21 topics. And these were topics based on this text that we were collecting for each rating, for each rating of negative societal impact in particular. So that's the data that we were looking at. And just to kind of parse out of those 21 topics, what we found. So kind of starting at the top, the first thing I want to point out is that we have some valence topics and that there's a heavy skew towards positivity in terms of the valence. So many people talked about the positive side of these algorithmic decision-making systems. Far fewer actually talked about the negative dimension. And if you look at the average score, so that's the numeric rating, there you can also see that even amongst the ratings that were negative, the average score was a 3 out of 5, so essentially a neutral rating. So it seems like there's very clearly some positivity bias in the crowd in terms of their rating of impacts of these systems. Societal domains, that kind of gives you a sense for the topical coverage of the database, talking about education, environment, healthcare, and so on. But I also want to kind of point out these impact types. These are kind of interesting topics. They kind of, I think, also still kind of demonstrate the positivity bias in terms of the numeric rating. If you look at something like financial costs, we have to remember these are algorithms in US government, so people were kind of commenting on the government spending money on these things, so that's kind of where that comes in, and you can kind of see a little bit of a negative balance on the rating there. But also this idea of this fourth one down called large scope. This is the idea that gets at kind of the magnitude of people impacted by the ADM in society. So people in the crowd were kind of picking up on how many people is this actually going to impact? And I think that's actually quite a useful dimension in terms of risk assessment. Finally, if we look at this last kind of broad category of topics, algorithm concerns, we see things like bias, privacy, and harmful results. And harmful results kind of is a catch-all for a variety of concerns that people recognize that get at the assessment of kind of intended or unintended results of these algorithmic decision-making systems. So I think one algorithmic decision-making system that we looked at in the category of harmful results was used for scoring high-risk areas for fire detection within a community. And the issue that the rater brought up was a concern that the algorithm could distract firefighters from fire prevention in areas that weren't flagged by the algorithm, so kind of diverting attention. So overall, I think if we look at these results, there's some hints that the crowd is able to pick up on some useful critical assessment, things about bias, privacy, harm, magnitude of impact, that they're considering different types of impacts, such as sustainability and decision-making, kind of broadly construed, but also, again, this predominant kind of positivity bias. Now, the other thing we were interested in looking at here was sort of the cognitive diversity element and the benefits of having multiple raters per algorithmic decision-making tool. So we for most ADMs in the database, we had about 5 ratings for each algorithm. And so we were able to look at, if we kind of randomize the order of those ratings and look at across topics, how many topics were identified for each algorithm in the database. So you can see as we go from 1 rating up to 5, we go from 3 topics up to almost 9. You do see some saturation for like the valence, which makes sense. But for things like algorithm concerns, those are kind of still growing, albeit somewhat slowly, as you add more and more ratings. So I think this is at least some initial evidence that multiple raters can also identify increasing range of impact in these algorithms. And I think the other benefit of having multiple raters is you can identify dominant impact topics and also consensus topics. So looking at if there's more than one person that identified the same topic. So again, in kind of summarizing this, I think this is kind of encouraging initial results that indicate the ability of crowds to identify impacts. We can increase the range of impacts identified with more people. Maybe this is complementary to more expert-driven evaluations, but we also need to address the positivity bias and probably iterate on the instructions in order to kind of steer people's focus and what they're attending to as they're evaluating these systems. Okay, so the last little bit I want to talk about here is about foresight through scenarios. So this is a scenario building is a very common methodology in future studies. Lots of people talk about developing scenarios to think about the future. If you get into more narrative kinds of scenarios, people even talk about this as sci-fi prototyping. It's kind of a way for structuring how you think about characters and events and plots and contexts and environments in a kind of a plausible reality. And a story is a really nice way to bring all those elements together in a compelling way. So here's sort of the cone of uncertainty as we go out into the future. This is kind of a common depiction of scenario writing where you think about different scenarios, different probable futures, different possible futures. And as you go further into the future, you have kind of more uncertainty, that cone of uncertainty increases. I think the important thing here is that, this isn't, writing a scenario is not about predicting the future. It's about exploring a range of possible futures, right? So foresight is about kind of understanding that range and encoding that range into a set of plausible stories that describe that future, or describe a range of futures, really. Now, in a paper a few years back, we actually took an anticipatory approach to developing scenarios to explore the implications of deepfakes in the context of elections. We thought that was probably one of the more compelling domains to be thinking about implications of deepfakes. This process was largely driven by us, the co-authors. I was working with Deborah Johnson on this, who is a computer ethicist, wrote the book on computer ethics back in the 1980s. It was really fun working with a philosopher, thinking through how deepfakes could impact elections, although neither of us had any real expertise in the domain of elections and politics. So I think that's a little bit of talking about expertise and epistemic uncertainty. That's probably something we could have done better to fill in. But in terms of our scenario development methodology, we sort of started with different conceptual dimensions. Things like, who are the actors who might do something with deepfakes in an election? What are their motivations of those actors? What kind of modalities of media should we explore? So audio, video, image, text. Phases of the election. When is the deepfake being deployed? Is it early? Is it, on election day? That kind of thing. Different channels of distribution, different mechanisms for influence. So how you might kind of use a deepfake to influence someone. And we knew we wanted to kind of cover that conceptual space with our scenarios, and we started writing plausible scenarios to try to cover those dimensions. But then we also thought, well, let's try to capture this idea of participatory foresight, and we'll go out and we'll actually ask crowd workers to write these scenarios. And that actually turned out to be an interesting exercise because, the crowds identified a few things that we hadn't thought about. And so even though we didn't take the scenarios directly from the crowd workers, we did kind of read those scenarios deeply and kind of work some of those ideas back into our expert scenarios. And of course, we did some scenario evaluation, looking at quality, looking at the consistency of the scenarios, the completeness, plausibility. We also solicited ratings from the crowd. So I think a nice way to incorporate participatory foresight for scenario building is plausibility. So people have different notions of what is plausible technically, socially, and they can read a scenario and say, that's not going to work. That's not how the world works. That would never happen. Or, oh, that actually seems like that could happen based on my perspective of the social reality. And so we kind of use that to hone down our scenarios. We did some editing, tried to improve the plausibility of the scenarios. I think we also got rid of a scenario that just wasn't going to be plausible. And we ended up with 8 scenarios. And then we kind of subjected those scenarios to some analysis, some ethics analysis, and also responsibility analysis. And so kind of some of the ethical issues that fell out of those scenarios were things like harms to viewers and listeners, deception and intimidation, harms to subjects like reputation or misattribution, persona plagiarism, that kind of thing. And then harms to social institutions like undermining trust. And then based on those ethical harms, we then looked at potential intervention strategies where we considered how platforms, journalists, news organizations, technologists, political campaigns, policymakers, and also individual citizens might be assigned responsibility. So this is something that philosophers of technology sometimes do, is responsibility analysis to see where in the sociotechnical system you can assign responsibility in order to kind of set expectations for behavior there, right? So the idea is that once you can set expectations, define obligations and duties, then it also makes it easier to assign blame and liability and identify entities, actors in the sociotechnical system that aren't fulfilling their responsibilities. So as an expert process, I thought this was pretty good. We tried to incorporate the participatory element to improve kind of the cognitive diversity, try to get some different perspectives on plausibility of the scenarios and so on. But we're thinking we actually want something more scalable. I mean, this took the two of us months and months and months of mapping out, stakeholders and thinking through scenarios and so on. So we're thinking we want something more scalable and something that can maybe more systematically tap into cognitive diversity to develop scenarios. So this is kind of where we're going with this right now. And this is a new project that we have going that we just started a couple months ago, where we want to essentially leverage written scenarios like we developed in the deepfakes work to better capture cognitive diversity through survey methods. So the idea is to sample different participants, like practitioners and users, technology developers, maybe ordinary citizens, to have them write scenarios for different kinds of AI technologies in society. And we also want to capture differences between societies, so like capturing participants in the EU versus the US to kind of study whether or not those different perspectives in society lead individuals to talk about different themes in the scenarios they develop. And we also want to add a policy dimension with all of this, AI Act stuff going on, and there are, some indications of potential policy movements in the US and also elsewhere in the world. We also want to kind of think about counterfactual policy conditions. So not just write a scenario, but write a scenario under, Article 52 of the AI Act. Like, how would that change the scenario? How would that change how things might play out in the future? So that's kind of what we're working on right now. We want to scale this up and basically capture thousands of different scenarios across these different dimensions. So I kind of want to wrap things up, and then of course I'm happy to hang out and take questions. But we've kind of talked about a lot today: prospective cognition, anticipatory governance, how we can use an uncertainty framework to think about reducing different types of uncertainty and foresight. And I showed you some studies looking at foresight and research, participatory methods, scenario building, different actors participating in foresight at different stages of the process. I kind of want to close here and try to connect this need for foresight and methodological development and standards back to an initial motivation around policy and regulation, which is to say, I think at some point we need to figure out accountability for foresight. So if we're going to talk about reasonably foreseeable foresight in the AI Act, we need to kind of have some definition for what reasonable is, right? So we need methods for foresight that are standardized to support these kind of proposals, which means we need to set expectations for who does foresight and for when it's done. And I think that's going to be really important for establishing forward-looking accountability. So I define this as a responsibility to develop effective foresight with expectations for explanation in the failure to provide effective foresight. So if you're going to create a regulatory regime around foresight, reasonably foreseeable risks and so on, then we need accountability for that, which means we need standards and methods that we can point to and say, well, you either faithfully executed this method and the foresight you generated is therefore legitimate, or you didn't use those standard methods to generate foresight, and therefore your attempt to generate foresight is illegitimate and therefore negligent, or that kind of thing. I think we could also talk more about whose responsibility and defining things like normative benchmarks of responsibility, who should respond to plausible impacts in society. You talked a little bit about researchers and asking researchers to develop broader impact statements. I mean, you know, we're all researchers. There's only so much you can do at the research stage in terms of mitigating. That's not to say that there aren't important things that you can do in your research to maybe try to mitigate potential risks. But many of the risks, I think, also appear at the deployment stage of the technology in society. And so I think we need kind of larger frameworks for thinking about responsibility. And also just more broad participation in terms of participatory methods for assigning responsibility. Thinking about responsibility assignment, maybe not so much as an expert activity where, you know, me and the philosopher get together and are thinking about, who should be responsible for this? But actually trying to bring kind of a more democratic element to that, where as a group, as a society, we can start to build consensus around who should be responsible for mitigating certain kinds of impacts that might emerge here. Okay, so I think I've said what I'm going to say. There's some papers if you want to read more about this, and of course I am happy to take questions. Thanks so much.